Click. All right, we are now recording. This is take-home test 3B. It's fall of 2022. And here we go. All right. So, so let's open the chat. Let me open the chat up again. So if you have a question, as usual, you can, I'll kind of keep my eye on the chat. But if I don't, feel free to, if I'm not responding, to jump in there and just ask me. Okay. All right. Well, this one, we've already talked about this in class, sig figs. I was going to do a whole nother thing on sig figs. We're going to go out in the hall. We may still do this, where we go out in the hall and we determine our pace, and then you got to figure out how many sig figs that would result in. So I might end up just doing that next semester, because I don't think we've got 1 day left. We're not going to get that thing done. So sig figs will be I know I've done a rather rotten job of teaching sig figs. Didn't used to. We'd spend 3 or 4 days on it in AP chemistry, but with AP physics, I want to talk about sig figs so you know accuracy, right? And keep you from getting thrown in jail when you're out in business world. And also see that people are BSing you all the time with what they're calling accuracy, which isn't accurate. So, and the idea of scientific notation and why humans react, we react slowly. So what is that? How does that affect what we say is true? So really, it's a pursuit of numerical truth. I think it's still important to talk about significant figures, even in a bit of a haphazard way. When it comes up, we talk about them. Okay. So once again, by May, I think you'll have a pretty good understanding of sig figs. All right. So we already answered this question. Well, okay. Let's just look at 16 since it's right there. Anybody got a question on 16 though? Just about, I mean, it's legal for me to put this on the test on Thursday, Friday. So you might have a question on that. It's easy for me to squeeze that in there. It doesn't take up much room. Who's got a question on 16 or one like that? Rafa says, shouldn't the second one be 3 sigs? Oh, great question. Okay. So Rafa asked a very good question. He said, shouldn't the second one there be 3 sigs? Because obviously, if you can say that something has a weight or a mass of 0.003 grams, that's very accurate, right? You had a pretty good instrument. So shouldn't it be 3 sig figs? But no, that's not the rules of significant figures. I didn't make the daggone rules up. I hate the rules, but this is what they are. Trailing zeros, as in the 4th one down, which says 5,000 kilograms, that makes sense to me. You know, it's 5,000. It could be 5,020. I don't know, 5,000. That makes sense. There's only 1 siggy. But if you say 0.003 plus or minus, okay, you're throwing a tolerance in there. Okay. I think Rafa gets a stamp because I think his question is a pretty smart one. Okay, if you see 0.003 grams, like in an article, you would give it 1 sig fig. But the fact that I put I put a tolerance on it, on top of it. So I think I was responding to the 0.003. Well, it's obviously 1 siggy. But then when you put the tolerance on there, you're saying, yes, my instrument can go to the nearest thousandths of a gram. So that one's tricky. I would take 1 or 3 there. Okay. So stamp to Rafa for pointing that out. Normally when you talk about sig figs, you don't put the plus or minus, but that I wanted to throw tolerance in there because really that's what it's all about, because as we did that lab, we saw that our tolerance was 0.15 seconds. A typical high school student, mine's 0.21, 0.22. How long it takes you to react. So I thought, well, let's throw the tolerance in there. But when you do that way, I agree with, I'm tending to now agree more with Rafa that I think that deserves that we are accurate to the nearest thousands. But I'm telling you, when you take PChem in college, you'll find that if you just written this 0.03, that's 1 sig. Okay, good. Well, I'm glad we talked about that then. Now let's go back to 15. After that, this is easy. 17. I wanted to point out here that you do need scientific notation. If you're going to say 1 sig or 5 sigs or 4 sigs, you can get away without doing it. But if it's 3 sigs, and so, the other way to saying that on the 4 sigs, you could say 2000 point. That's the kind of the quick way of doing it, which is now accepted. And the correct way is 2.000 times 2. That way you're spelling it out that all 3 of those zeros are significant. To do 3 sigs, as you know, 2.00 times 10 to the third. Okay. 2 sigs. Yeah, we did 2.0. Okay. So any other questions on sigs? All right. And you can always ask tomorrow, or you can text me later or whatever. You know, it doesn't bother me. Davey ain't known here, but Davey and I text all the time. We'll text, we'll go back and forth for hours sometimes. It's fine. You're not bothering me. Now, if I had 50 texts a night, that would be a little rough, but until I get that point, I don't mind you guys texting me a question about physics, and we can do a one-on-one. It's slow motion tutoring. All right. Now we get to this one, make up 4 vectors. And we did talk about this in class. I made the mistake on GroupMe because I remembered a problem that it had 5. I just assumed that it had 5. No, there's only 4 here. So I said pentagon. No, it's not a pentagon. Because when you rewrite this, okay, I have the answers here. When you rewrite this, you can rewrite this as this. This is what I would do. The best way to solve these is you would just say A plus 2B minus 5C plus 3D equals 0. If you just say it that way, then you know that those 4 arrows will come together to make a quadrilateral. It doesn't have to be a square or a rectangle, but it'd be a quadrilateral. And the hard way of doing it, I sketched it up here. I saw some of you doing this, and there is nothing wrong with that. That is a perfect way, and I would certainly accept that on the test. But to me, you're making it a little harder on yourself, a slight bit harder. Easier just to set it all equal to 0 and make a. So if they were 6, first person to answer, what would that figure look like? And you get a stamp on the chat. If it was 6, you'd get a looking at the chat. If there were 6 vectors, or I say it's 2A plus 5C equals negative 2B plus, and there was a total of 6, and you drew it, what would it look like? A hexagon. So Rafa is the quick man on the keyboard there. Okay. Oh, now notice what I did here. See that? I told you guys, just go ahead and just call it negative 5C, which is fine. You can do it. You just call it negative 5C. But if you want to call it 5C, you got to flip it. This is not, you might think, well, ASCII screwed up because that's head-to-head. You can't have head-to-head on a head-to-tail method. But remember, that says 5C. If I flipped it, I could flip it here, flip that arrow, and just call it negative 5C. And that's saying the same thing. Okay. So either way is fine. Okay, we good? Thumbs up to go on. Finn is the fast kid. He's always the fastest on the thumbs up. Finn is always ready to move. Megan says, let's get out of here. Trace says, yeah. Okay, let's go. So now we're on 18. It's one of these essays, and I stopped 20 years ago. I would write out the essay as I like to see it. And what would I get back on the test? Exact same thing I wrote. So I don't like write the essay out for you to, I see I can't spell. I don't write the essay out for you to copy. I want you to come up with your own words. So I'll just say this. I'll talk about the main points I want to see here. And the question is, why did we go to the stadium? We went because when we dropped the balls in the classroom, we couldn't get the time above 1 second. It was like 0.67, something like 0.72. Nobody's ever doesn't take the ball more than a second to fall from our ceiling to our floor. So the problem there is that our tolerance is so poor because we're humans and our reaction's so awful that plus or minus right here, that plus or minus 0.15 makes that 0.7, that 7, the digit right there, the tens digit, iffy. And as you're reading the number left to right, the first iffy is the last sig. He said only has one sig fig. Nobody, maybe in kindergarten, but nobody in the right mind would ever do 1 sig physics. You'd be laughed out of the place. Tell you the truth, 2 sig physics isn't so accepted either. But we're high school and we have, we don't have the best instruments. You need really 3, 4, 5 sig physics, depending on how far up you go in college. So we went to the stadium to get the time above 1 second, because once the time here is above a second, I know that 1 is correct. The 4 is iffy, but that's the 1's good. That's a siggy. The 4 is iffy. That's my last siggy. So now I have 2 sigs. And so when I'm doing my calculations, and I should have called those up, when I'm doing my calculations, I can now end up with 2 sigs in my answer. And let me point this out. Don't do what I did when I was in PChem. The professor, Stan Neely, got mad at me because I was trying to be a purist and try to propagate error as I went. So as I measure, I would make the sigs correct. Well, what that does is it propagates error throughout the whole problem. It's a pain in the butt. You've got to worry about sig figs all the way through. You're gonna have a heart attack. What he said, Ask, just wait till the end. I had his daughter in class. I was in grad school, so he knew me. He said, Ask, just wait till the end, and then let your numbers flow off your calculator. And then at the very, he's the head of the chemistry department at OU. Okay. He said, just let them flow. And then at the end, round and truncate. So you look for your weakest link. Go ahead and run your numbers on your calculator. Look for your weakest instrument. If that's a tolerance is such that it's going to limit you to 3 sigs, at the end, say your answer on your calculator, you do all your dividing and your squaring and blah, 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 and you get 3.8604, and say it's grams or whatever. Say, okay, I'm going to now round and truncate. I got 3 sigs. So I leave that 6 alone and get rid of those 2 and just call it 3.86 grams. You see? Okay. Anyway, the point to this whole problem was we went to the stadium to get the time above a second. One year it would not stop. It was cold. It was rainy. We could not find a day to go. So we had to go to the North Gym and try to jump. And then when we would drop it from the North Gym, it still was like, 0.9 something seconds. Could not get it to it. So I got a ladder and I climbed those little ladders that kind of stay. I climbed it and then dropped it, and we got like 1 point, I don't know, it was 1.05, and we were all cheering because we got above a second. Okay, that's what you're trying to do. And then I would go to the roof of the science building and drop it, then we get above a second. All right, so that was to gain a sig fig. Questions on that one? There'll be some kind of sig fig question on there. I haven't totally finished writing it yet, but I think I squeezed one in there. Keep going. Thumbs up. Up, Finn, fast man. He must put his finger on that button. Just wait. Okay. He doesn't like to mess around. Now we get to this one. Okay. Look, this is a little ahead. We've done tons of head to tail, but I wanted to show you, and if you go to GroupMe, you'll find an example, and you'll find a link to a video of me working this. Well, not this one, but working one like it. But in the video, be advised, because it goes on to do all 10 steps. All I really care about right now is the first 6 steps. And that's what this does. I'm gonna take the time to work this one with you a little bit, because I know this is still kind of new to you. We might go over past 9:30, but that's okay. You can jump in, jump out all you want, and then I'll make a recording. All right, so let's look at this one. This is just a sketch. That says show your work on the sketch area. You don't even need a ruler. Okay, so this is not construction. When it says construct, that means get out a ruler or get out a protractor. But this is a sketch. So we're going to sketch these two. And the only reason we're sketching it is so we get our signs right. All right, so F1 is 18 newtons. I always do the big one first. 65 degrees north of east. So this is, and I'll have the nice finished product here in a minute. There is F. So if you're watching the recording and you just want to get to the answer, just feel free to fast forward. It's not going to bother me. I don't even know you're doing it. And that's 60 degrees, 65 degrees, and that's 18 newtons. Okay. I sketched it, right? I'm freehanding it. It's okay to have old shaky hands going here. And then on this one, the next one, that's F1. F2 is 7 newtons, 30 degrees north of west. So something along that line looks about like that. And that's 7 newtons and 30 degrees north of west. Okay. Well, I now have, I say you're adding, when you do component method, you know what? You're not adding arrows, you're adding rectangles. You can add right angle rectangles to each other. As crazy as it sounds. So I have this rectangle. Hello, it's getting late. Triangles. I don't know if you can add rectangles. You can add triangles, though. Right triangles. So I'm going to add the blue right triangle to the purple right triangle. But I can't say, for goodness sakes, don't give me a heart attack. Don't say 17 plus 18 plus 7 is 25. Oh my gosh. These aren't scalars, okay? They have a direction. But so what you got to do is you got to apples to apples, oranges to oranges. You have to look at X versus X, Y versus Y. All right. So I have to take this 7. I have to take this one and break it up into its X and Y components using sine right triangle tree, right? Sine and cosine. So always sine for the opposite side, cosine for the adjacent side. So I'm not going to bore you by going through this whole thing, but I'll show you the answer in a minute. But this will be 7 sine 30, which is 1/2. So this is 3.5. This leg, this is 7 cosine 30. All right. This is 18 sine 65. And watch your signs, right? This is actually -7 cosine 30 because it's going backwards. Okay. Everything else is positive here. And this is 18 cosine 65. So remember I said that every major concept is introduced 5 times. This is really probably we've talked about vectors a lot, but stack and rack, this is like the first or second time it's been introduced. So I'm trying to keep it simple. Well, then all you do is you put your I roof and your J roof. So for F2, I already have one of these figured out. This would be 3.5 purple, 3.5 J roof. Then you have, these are newtons, okay? So let's cut to the chase here. I know you guys got a lot to do. There's that's actually with a protractor. I want to make it look nice. All right, so there's my 2 right triangles, my I roof and J roof. And then when you do this, when you put those together, okay, so that's the X version. I don't know why I blocked that out. So I went blue for J roof. I went orange for I roof. Okay. Now I take those and I stack and rack them. So let me slowly unveil this guy. For F1, it's 7.6 over and 16.3 up, or east, north, whatever. These are map views. So 7.6 I roof east, 16.3 J roof north. Okay. And then for the F2, when you do that math, you get negative 6.1, so west, and 3.5 north. Newtons. Okay. Newton's a unit of force. All right. So now all I got to do, that's my stacking. Now racking is just add them up. So there you go. 7.6, add them or subtract them, whatever it is. Here's probably one of the main mistakes students make is right here. Right here. They forget to make it negative. Like they'll make it negative over here, then they'll forget to bring the negative over. Okay. Anyway, so when I add those up, I'm really subtracting those two. And you can see from here that 7.6 and the negative 6.1, they're fighting each other, right? They're going this way. If you can see me, what I'm doing, they're fighting each other. The J roof is helping each other. They're both going up. So that's an addition. And that's as far as I want to go right now. We'll get to the other 4 steps in packet 4. Okay. Questions on this before we move on? Looking, giving you time to think. Question, formulate your questions. All right. I'm guessing though, we're going to move on then. We're going to move on. All right, we get to this one. This caused much gnashing of teeth at Panera Bread because you know, it's kind of tricky. I promise you, there is one like that on the test. It'll always be on there. So it's a little puzzle, and you got to put these together to see which ones work, which ones don't. I'll tell you 3 work, 3 don't here. So we go through. You just have to. It's a process of elimination. You've got to keep messing with them. So, like for instance, A plus B plus C equals E. Is that true? Well, I just take a look at it. A is here. Okay, so far good. So far so good. B, that's head or tail. So far so good. Whoops. C, nah. That's not even. C isn't even. No. That won't work. Let's go to this one. C plus E equals B. C, okay, there's C plus E equals B. That looks right, because B then would be the resultant. So I'm going to circle that. Looks good. Okay, no one's asking questions here, so I guess you're getting this. Then it says B plus the opposite of D. So you got to flip D. So now, if I erase that, oh, I'm going to ask you whether you like this method we're doing with the zooming and all the stuff, or you like what we did on 3A, which was the, you know, every day we just show you the key. And I don't know. We may do the same thing. The A take-home test will be every day showing you keys, and the B take-home test will be the going to the restaurant and then zooming. I kind of like it. Anyway, B minus D, so flip B. So B, here's B, flip it, flip D, make the arrow go this way. So far, so good. Equals A. No, why not? That looks right. Someone tell me how can I fix it? What do I do to fix this? How can I fix this? How can I fix that? I can fix it very easily. Yes. Rafa, where's the rest of you guys? It's kind of like Flashback Friday. Rafa's now answered 3 questions. Now he has to sit out and somebody else has to answer. So if I said equals negative A, that would work. Okay. But I didn't, so that's a big no. All right, same idea. Let me cut to the chase. This is supposed to be a video key. And those are the ones that work. The ones that circled work, the other ones don't. Who wants to fight me? Oh, Shargo is saying, yeah. Shargo is agreeing in his own way. He said, well, if you A is going the wrong way. All right, so E minus D minus C plus A, because I don't know why I did that. I guess because I was looking, a lot of times setting them equal to 0 helps, because you go, okay, do I have a figure out of that? So I guess that's what this is from a previous discussion from a previous year. I guess that's what I was saying there. Okay. Questions? Anybody disagree? I'm not saying I could be wrong. Not all these are vetted. A lot of these questions are vetted. I mean, years of students have done them, but some of these are new or been adjusted somewhat. All right, I'm gonna keep going. Thumbs up. Finn, first one on the thumb. Okay. All right, let's keep going. 21, Raffo climbs to the top of the harv and throws the ball. Mason agrees to catch the ball down below. All right, so this, you got to think, well, which blue equation am I dealing with? Is there any time given? See, if there's no time and I'm not trying to find time, then automatically you'll go, okay, so we're doing third blue. V final y squared equals V naught y squared minus 2g delta y. We're doing third blue. Okay. And then it's a matter of just watching your signs, because positive, negative. So let's go over here and take a look at it. I have a drawing. Okay, here's my drawing. Drawings are really important. Okay, so there's my drawing. The delta y, one thing to remember, delta y is a negative 10, because Raffo being the origin, the hand that the ball leaves is the origin. So anything below him is negative. Okay. So that's your drawing, and then just there you're gonna plug into your third blue, solve it. I'm solving for V final. I just take the square root, blow this up a little bit so you can see it. Okay, I take the square root. Okay, so that's something that I got a question about. I said, wait a minute, it says, someone said it's 11.2. Why are you making it 10? Because his outstretched arms, he's going to catch that ball. He's 120 centimeters outstretched. So the ball won't fall 11.2 meters. It'll fall to his outstretched hands. So really just it falls 10 meters. That's where that 10 comes from. Okay. And then it's from now on just plug and chug. And so let's go ahead and cut to the answer. Yeah. Mason's got to catch a ball moving at about 20 meters a second. Twice as fast as anybody can run. So that's a pretty fast moving ball. Okay. Keep going. Now at the end, I'll tell everybody good night. And then if you want to stick around and go, hey, can we go back and look at number 20 again? We can do that. All right. Sometimes that post Zooms are the best questions I get all night. All right, let's keep going. We get to Coach Cole. And I had to change this. When I wrote this, I thought it worked. I wanted to keep it close, but I made it too close. And so that 33 meters a second, you're going to get into imaginary numbers, which do have a place in modern physics, but imaginary numbers have no place in classical physics. Okay. In fact, tomorrow, when we're looking at Schrodinger's equation, wave mechanics has imaginary numbers. But classical physics, no imaginary numbers. So I had to make that 34 meters a second. Okay. So let's take a look at, here's my drawing. Okay. A drawing is really, I know some of you seem to think that a drawing is a waste of time and you want to get right to the number crunching. Man, that is that's a rookie mistake. You want to take your time. I know you're rushed on a test. You won't be so rushed. The good thing about Thursday, Friday tests, you're going to have, well, you normally have like 55 minutes to do one page front and back. You'll have an hour and 15, hour and 20 minutes. Okay. You'll have plenty of time to kind of look through your screenshots. I mean, not screenshots, but reference sheets, look through your notebook, and you can handwrite any problem here you want. You can handwrite. I don't want you cutting and pasting though. You can handwrite it into your notebook. All right. Okay, so there's your drawing. He throws it up because it says throws upward. All right. So what equation we're going to use? Well, it's once again the third blue, only this time you're not looking for V final, you're looking for V naught, right? Yeah, you're trying to find what velocity must he throw the ball up at so that it hits the ground at 34 meters a second. And so, see what I did there? I just switched it. I solve for V naught rather than solving for V final. So you think you're cool, everything's great, but then the students that came to me on this one, usually it's a sign problem. So when I plug my numbers in, I'm gonna blow this up. When I plug my numbers in, your V final Y is a negative 34, but it doesn't matter because you're squaring it anyway. And then, so you could have got away with that messed up sign. Plus 2 times, but see, the delta Y is a negative 56 meters, not positive. Okay. So, okay, now hold on a minute. This is where I got in trouble. When I wrote that 33, I thought that's good enough. But then when you look at it, that you're going to end up subtracting that inside the radical because that negative 56. So that's where I end up with unless I made a mistake here, you guys can check me. No one's really checked me on this. So those are the numbers I got. I double checked that. 1156 meters squared over second squared minus 1099 meters squared over second squared inside the radical. Okay, so we punch, and we get, I got 7.55. I took the square root. So this is brand new. I'm thinking that I usually make a dumb mistake somewhere. I'm good with the physics. It's the mathematics, the arithmetic that messes me. Who has a question on, or a correction, or you're the first ones to see this? Comment. So I guess we're all in agreement. Okay, who's ready to go on to 23? 23 is the hardest problem on the test. By far, in my opinion. Okay, let's go thumbs up again. Finn. Oh, Raffo beat Finn that time. Finn, number 2. There comes Owen in at third. 3 is not enough. We got to have more. Nobody else. This is Reaper want to go on. Oh, Finn's upset. Okay. No profanity though. No, okay, that's not profanity. All right. Okay, we're good. Keep going. 23. I wrote this back when we were having all these earthquakes, And so I don't know if you remember, there's a moon hanging from my ceiling, and we measured it actually. It is 94 inches. I think I'm pretty sure that we actually measured that thing. So it's 94 inches from that moon to the floor. And so it's, let's say it's hanging and finally it kind of comes loose and it falls. And so your question is, how many milliseconds will it take to go the last 6 inches? I mean, who cares, right? But that's the question. So I said that you must use the blue quad on this one. And this was probably the most asked problem at Panera. Okay, so here we go. Let's take a look at the drawing first. I broke this up into 2 phases. Now, Rafa did it a different way than I did, and his way, I think, is perfectly legit. My way is I went ahead and the purple of my phase 1, it's the purple phase. I said, well, let me find the velocity. Now, initial velocity when the moon's hanging there is 0. Let me find the velocity of the moon right as it hits the 6 inch above the floor mark. That'll be my final velocity in the purple phase, my phase 1, but that translates to the initial velocity in the second phase. Now we work these second semester, we work these problems, which you'll need. The first part takes you to the second part, takes you to the third part. And so the V final of the first part's the V naught of the second part's the V final of the third part. So that does happen when you have these more complicated situations. So it's a little practice at that. Okay. So are we clear on that? that idea. So now it just comes down to working two separate problems that are connected. This happens a lot when you do conservation of momentum problems, which we'll get to in packet 4 or beginning of packet 5. All right. Packet 4 has got a lot of calculus, a lot of derivative calculus in there. Packet 6 got a lot of integral calculus in there. All right, so here we go. And this is a nasty problem, no doubt about it. So my strategy is, like I just said, I'm trying to find the V final using third blue. So in the first phase, once again, I use a lot of third blue. I don't know why I went crazy on third blue. Third blue, and then come down. Now V naught, I get the break that V naught is 0 when it's hanging there. And so my delta Y is not 94, right? It's 88 or negative 88. So I plug that in. And I see my mistake. I had the negative there, but I forgot to put the negative there. Okay, that's a negative. There's a negative right there. Otherwise, I was freaking out. I thought, oh my God, I'm gonna have a square root of a negative number. But no, it'll always work out. If you find you're getting a square root of a negative number, you made a mistake somewhere. You see, this is what it's all about right here. On blue, that is the biggest bugaboo about blue equations. Is sign everywhere a sign. Okay. 5-man electrical band, 1974. All right, so you plug that in. Now I did do a little bit of maintenance there on that 88. I had to get it to feet. So I just quickly stuck in a little unit analysis. That shouldn't freak you out anymore. It's just what you do. So I got that, that'll get my 88 inches into, and you could have done it off to the side, then plugged it in. I'm fine with that, but I like to show you because it's a key here, right? So you punch all those numbers in, and I'm a little bit leery of my own work here. I don't trust myself, my fat fingers when it comes to calculators. So let me know if I'm wrong. But when I did that math, I always double check this. I got 21.7 for V final Y. Negative, because it's going down. That's a really important negative there. So it's negative 21.7. Okay, are you with me so far? Looking at the comments, everybody seems pretty quiet. Okay. Let's get rid of that guy. Kill that. And now we go to phase 2. Phase 2 now I'm going to pick up where phase 1 left off. So the 21.7, negative 20, Finn said I used 9.81 and converted the delta Y. Yeah. Okay, and I saw the students do the same thing. What Finn's saying is here, he went ahead and just, instead of saying 32.2, because it's not Crazy Joe, you know, he just said 9.81. Then he just converted the inches to meters, I guess. But I didn't give you that conversion, but you could look it up. 2.54 centimeters equals an inch. You could do it that way. I have no problem with that. All right, but you know, I kept it in feet and seconds. At the end, we can compare and see if we agree. All right, so then, but still the same physics, just different math. So then the second thing is that the final velocity there of the purple phase, phase 1, is now the initial velocity of the blue phase or phase 2. Okay, so now I'm going to do the same. No, now I'm going to use, I'm trying to find time. So now I can't use third blue. I have to use second blue. I can't use first blue because I don't know final velocity. So I have to use second blue, which then, and this is going to happen tomorrow in class, that means I'm going to have to use the blue quad. But it's no big deal. It's like the orange quad. It's very similar. And you'll get the blue quad, of course, in the reference sheets. In fact, blue quad, I think, is one of the last sheets. It's the second to last sheet or so. You'll see at the very bottom, it'll show blue quad. That's why you downloaded those 31 sheets, but that doesn't mean you're done. I know you have a little extra time, but on Thursday or Friday, but you can't just be scrolling for 15 minutes trying to find a formula. you should familiarize yourself before you walk into the test. So you know, oh yeah, I know about where that is, then you can find it much quicker, whatever you're looking for. All right, anyway, so I'm gonna have to use blue quad here. And that's the blue quad. And then it's a matter of plugging in numbers, watching your signs. First time I did it, I didn't watch my signs close enough, and I was going, what's going on? I was pulling my hair out. All right, so let's get rid of that. Let's get rid of that. So here we go. The rest of it. Let me plug in my numbers here. So plug in my numbers. Let's emphasize that step. I'm going to stop for a second. We're okay on time. This is the hardest problem. I got to spend the most time here. Yeah, see, the first time I did it, I didn't make that. I kind of just forgot about it. It didn't bother me that I left off the negative here because I was squaring it, but then I didn't make that negative, and I was going, oh my goodness, there's no way that time's right. So then I went back and said, okay. And that's why knowing, I mean, I think I got, when I left that 21.7 positive at the first, forgot that it was going down or make a negative. I got like 1.5 seconds, and I knew enough to know you have to, that's why you have to know something about the world or the universe. Well, that's crazy because I know it took 0.6 or 0.7 seconds to fall from the ceiling. So that helps you to go, oh, I made a mistake. Went back and looked at it. Of course, you change, obviously, you're going to change that 6 inches into feet. So negative half a foot because it's still going down. So a negative plus, negative minus a minus makes it a plus. Okay. And keep going. Now it's just plug and chug. And I ended up with 21.7 milliseconds. Can I get an amen on that? I mean, who show me your numbers. Type in your numbers into the comments. What'd you guys get? 22, fine, 2 sigs. And to be honest with you, it probably is a 2 sig problem. Let's go back and look. Yes, no. Yeah, no. Oh, yeah. Because it says 6.0 inches. That's 2 sigs. So Rafa's looks actually a little more correct than I am. I was being lazy, but he's right. I would take 21.7 as an answer, but the better answer is 22 because you're limited. And I'm not going to play that game. Oh my gosh. It just drives me crazy. I always get those students that just latch on to sig figs. They're always correcting me in class. In general, unless it's a sig question, in general, 3 digits, 3 sigs is always cool. That's what AP physics test says. It says 3 sigs. It says right there on the test, 3 sigs are always cool. It doesn't say always cool, but it says keep your answer, about 3 digits. Evan said I got 73, but I'm not sure where I went wrong. Anybody else get 73? You know what I'm guessing, Evan? I'm guessing it's a sign issue somewhere. I bet. I need a little more help. Rafa agrees. I need like Megan to agree with me, or somebody, or Trace, or Owen, anybody on here, somebody else, either Owen. I'll take it. I need a little Tatum. I mean, you guys are everybody on here is brilliant. So you guys give me a Evan said I did unit analysis early on and converted it into inches per millisecond. That's fine. You're asking for trouble, Evan. If you tried to convert the acceleration because you're squaring the seconds, people get in trouble doing that. That might have been where your issue was. And we can look at it tomorrow. Trey said, Trey, okay, we're cool then. Trey said 22 milliseconds. I think we're good. All right. Now let's keep going. See what a mess that was. If I put that problem on there, I'm going to have to give you some time to work it. Well, you have extra time. Okay. Now let's go to these. And we did this today in class. Remember the window shade stuff. So this is all window shade questions. These are the 7 situations I'm talking about. So I'll unveil each one of these. Situation one, you drop a ball and it lands below you. So it's a lopsided, it's not a perfect bow tie, it's a skewed bow tie. Oh, you dropped it. It's not even a bow tie at all, right? It never went up. So it's, my bad. It's not even a bow tie. You dropped it. Now, so that's got to start. I'm always surprised at how many students miss these. There's only 7 situations, but they get mixed up. I might quibble with myself a little bit. I'm not crazy about that, about what I did there, about this, because it's supposed to start off flat. So let me redraw that. If I saw you do that, I don't think if it was worth 30 points, I might take off 1, because I think I'm being a little picky, but I think that's not very, that needs to be a little more flat, because it starts off with no slope. See, no slope. So this guy should be more flat and then come down like that. A little flatter on top. Okay. Yeah. All right. Let's go to the second one. You throw a ball down, like this is the same thing as Raffo throwing the ball down and then Mason trying to catch it. So you throw a ball down, lands below you. We've now shut that left window, that left shade, not shut it, but we moved it all the way over. So this one looks like this. Now, I think 6th hour, I showed this to them. You can dot this back, dot. And that right there, that I used to make students do this, and that lines up with that flatness up there. That should be flat right there. And then by the time, see, so by the time you get to this point, it already has a slope. Okay. All right, so because it starts off with a negative velocity. Of course, this bottom, that's easy points for you. That'll always be worth a simple point there. You can just call it, if you just want to just call it, go ahead and just say negative G every time. Negative G, negative G, negative G. Okay, the next one, we throw a ball up. It's caught before it reaches the apex. Okay, it reveals this. Oh, don't do that to me. All right, it reveals this. Let's take a look at it, blow this one up. So I'm throwing the ball up, which means my initial velocity is positive. See, oh, it must have got messed up. There you go. Nope. That's what I wanted. Okay, that's fine. Extend this axis up a little bit. Okay, so I'm starting here. There's my V naught. That's V naught Y. Starts with whatever, 50 meters a second, whatever it is I threw it up at. It's like you're throwing your keys up to somebody. They grab the keys out of the second-story window before it reaches the apex. They catch it on the way up. Okay, so this really sloppy. I apologize. This key is awful. So this is going up, but it's still rising. It doesn't reach the apex yet, so it doesn't flatten out. It's still got a positive slope. Okay, these two have to line up. This has to line up. The wherever you end has to be the same as that. It's not a bow tie again because it never reached the apex. Okay. And the last situation we're looking at is you throw a ball up, it reaches the apex, then it's caught above you. I said 1 second later, just so it's not like immediately caught, but it comes down a little bit and it's caught. So this is it's all messed up here. That's why it's all messed up. There we go. Okay, let me make that look prettier. There you go. That's the apex. This is terrible. Okay. Yeah, that's better. All right, so that's got to line up. I apologize. I thought I had this nicer. All right, so that's got to line up with the apex. Okay. It's a skewed bow tie. It spends more time going up than going down. So my yellow triangle represents, remember, this is the, I'll blow this up a little bit. This is the ups. This is the ups. This is the downs. The blue there, that's the downs. Spend more time going up than down. Okay. Good. Ready to keep going? Once again, Finn won that time. Megan came in second there. She said, get on with it, dude. All right, so here we go. 25. We're almost done. No one asked about 25, but I guess I know why, because it wasn't assigned until today. So 25, you have to show it's the same object. Now, people think that this means the object is going in projectile motion, like I'm throwing a basketball. No, this object is going straight up and down, okay? It's just we're looking at it through time, okay? So you're supposed to show, it says show the velocity vector and show the gravity vector. Well, this kind of refers to the next problem. It's in a gravity field. And so gravity vectors, it is a field vector. And so you can just put a bunch of these arrows down if you want and make all these congruent. And so it's affecting the ball all the way along. This is my G's. It's 9.81 or whatever you want to call it. Well, 32.2, you know, but if we're on Earth, it's 9.81. So that's a field always pointing down. Now we look at the velocity. Well, initial velocity is up. I'll just make a arbitrary length here, but it's up. Okay. But as it rises, this blue arrow is getting smaller linearly, not parabolically, linearly, because remember, it's a linear function, v versus t. So this is smaller, and I'm not going to get the ruler out and all, but it's just smaller. I'm fine with that. Now at the apex, what's my blue? How big is my blue arrow? Zero. So right, Rafa says 0. So there is no arrow there. No arrow at the apex because there's no vertical velocity. Then this, notice that this is supposed to be, anyway, if you didn't notice this is supposed to be the same height. I have a whole video on this, I just remembered. Anyway, this goes down, and it's you've got to show congruence. These are congruent, equal but opposite directions. Assuming no air drag, no energy is lost. Gravity is a conserved force. It gives and it gives back. So that's it. I think you're done. Ball's caught, never makes it back down to the ground. And here is my official key. Yeah, I threw some numbers in there, said what if, but don't worry about that. I better erase that or someone's going to think they're supposed to have known that. Let's get rid of that. That is 0 there. I don't know what that happens to be. Okay. Questions. Last one then. Last one. I'm going to make it by 9:30. Here you're supposed to show 3 vectors. You're supposed to show V2, V3, and the change in the position. You know what this one's like? This one's like those other ones we did on the previous test where you had to do the, sideways trios. It's the same idea. It's a vertical trio. So the acceleration, it's a gravitational field. And so that's, no matter where you go on this grid, A is always going to be whatever that length is. Looks like 2 squares pointing down. Okay. So here we are at 0 seconds, at 0 seconds, at 1 second, and at 2 seconds. And so we look, now we kind of go back to look at the grid and we go, okay, that's a puzzle. What can I gather here? Well, the initial velocity looks like it's 2 grids long, whatever those are, meters per second, whatever it is. So then the second time I look at velocity, V1, it is 1, 2, 3, 4 grids. So obviously it's growing by 2, right? We've done a problem like this. We just did it horizontally. Now we're doing it vertically in a gravitational field. So this guy is going to be 1, 2, 3, 4, 5, 6. Okay. And that's the easy one. I mean, it's all new, so I can't say it's easy, but All right, then we get, and then we do it again. We can do another velocity, pick it up right there. Here's the thing. You want, this is a little bit tricky. You want that object to be where delta y tells you it is. Well, this, see the red arrow? This is pointing, it tells me where my V1 is, where my object is at the end of whatever the time is, whatever the interval is. And then delta y2, I know, 1 second. Okay, and then delta y2 tells me where I'm at 2 seconds. Well, before I can do V3, before I can do this one, I've got to figure out where am I, right? So now I've got to go to the red. I've got to go to this parabola. This is going to be a parabolic. So it starts at 0, comes down. It had a little slope to begin with, but this is going to come down if I'm connecting tips, like we did on that last problem, last test. Then this is going to connect tip down there. The question is, where do I put it down there? I mean, I could probably kind of wing it on a test and maybe get away with it, but where does it go? And so the only way to do that, I think, is to do a little math, which I did here. Okay, let me unveil this because we're out of time. There's my math. I used the second blue equation to find out where to put my the delta y grows parabolically, where to put my delta y. I went ahead and showed y4. I didn't ask you to do that, but it looks like I did show delta y4. Delta y4. Okay. Delta y3 though, so I got that by plugging in 3 seconds. I know v naught y is -2. I know g, according to this, g is 2. Oh, g itself is 2, right? G is never negative. I hardwire that negative into the equation. T squared is 9. And so when I do that, I get a delta y of -15. That's where I put my third one, -15. Now I know where to start, where to draw the V3. I'm saying V2, V3. Where to draw the next V will be where that object is. And I know the V is always going to go up by 2. But that's why I had to use that equation. This is it. If you're not getting this, it's like what we did on the previous test, only we were doing it for the X, now we're doing it for the Y. Okay. Questions on that? Yeah, I agree. It's not pretty. But something I made up. I thought, well, I'm trying to get you to understand fields, accelerations of field. They're called field forces. People are asking me to take my shirt off. I will. I'm not in. I don't feeling it tonight. I'm not feeling it. No, but before the end of the year, 100% guaranteed. All right. So, questions? Oh, Evan says, is it just a coincidence that each velocity starts at 1 more than the last one? Hello. I started my velocity. I let the delta y tell me where to start the velocity. Okay. There's not a lot of coincidences in physics, so maybe there's a reason there, but I do agree with you that it seemed to be happening. I don't know if it would have happened again on V4. Anyway, kind of a goofy question. You gonna see that on the test? Nah, I was just messing around. You won't see that on the test. Finn said, you said you wanted to copy from from these take-home tests by writing it by hand. Yeah. You cannot photo. No. I mean, I'm saying if I catch you, you can't do. I got to take the notebook away, so you can't photocopy. Okay, if your question is you photocopied the test question and then hand wrote in the answer, I'm okay with that. Yeah, but what I don't want you to do is just like what kids would do is they would wait till the key came out, which would be coming out, you know, well, now it's a video key, so you can't really do that. But they would just tape the screenshot or whatever, they would just tape that in there. But if you handwrite it, they at least know you thought about it. I'm trying to get you to think about it. Okay. Okay. Yeah, now, Fan, you can leave it in there if you just taped in the questions and then hand wrote the answers. That's okay. Okay. Anybody else got a question? Let's move this up a little bit. All right, so now I guess I'm going to officially say, now we're into overtime. So I'm officially letting everybody go. Of course, you could have gone anytime you wanted. And then I'll stick around to answer questions if you got them. Thank you all for coming. We're down to Matt, Trace, and Owen. Shargo sticks around. Matt and Trace. Questions from you guys? Trace said, could you explain situation 3 on number 24 again? Yeah, question 3 on 24. Okay, so situation 3 on 24. Here we go. Yeah. So this one is not the best drawing in the world, but the situation, let me clean this up a little bit. Keep moving this thing around and all right. So, oh, it's terrible. Let's just start over. All right, so this is a situation where I throw the ball. So that's my Y versus T, and V versus T. Of course, we know what A versus T looks like. So Y versus T, V versus T. So now I throw the ball up at a certain speed. It doesn't ever get to the apex. So that's like that. So this would be some kind of trapezoid, the area. And now this guy is heading towards the apex, but it never gets there. Okay, it's still going up. It's not linear, but it's still going up. Now, if I were to continue, if you were to continue, which you didn't, but say fake it out and continue, then it would reach the apex right there. It never got a chance to, because someone caught it before it reached the apex. Okay, does that make sense? Okay, thanks. All right, anybody else? Matt or Trace, questions? Okay, Matt, any questions on this? Going once, going twice. I think you might have stepped away. Let's see. You write any question out? No. Okay, I'm going to assume you stepped away from your laptop for a minute. So I'm going to go ahead and stop the recording. Stop recording.